Hello guys, my name is Fred, and I'm the tech lead of Beamer. And we believe that scaling Ethereum with rollups enabled a whole new design space for applications, but it also introduces a new problem with a growing complexity in UX. So today I'd like to walk you through our research process at Beamer and what we think is the problem with a rollup-centric future, what is the current state and what we need to do about it so that we really can achieve mass adoption on Ethereum. So because we believe the UX is currently the biggest blocker, one of the biggest blockers for mass adoption on Ethereum. So scaling Ethereum is in full progress. We have seen exponential growth in the past year, users, dApps, and liquidity escaping Ethereum onto rollups. And this is a continuous progress, and we see a lot of rollups coming up. And this is also one of the things Vitalik mentioned in his blog post, what we need to achieve for mass adoption. However, escaping to rollups introduces fragmentation. Users, liquidity, there's really a whole set, like a completely new problem which is introduced by this horizontal type of scaling. So this is really what we think is not going to allow for mass adoption if we don't fix this problem. And it's actually not only the users, also the dApps have this problem of fragmentation. They see users and liquidity on different chains. So what they have to do is they have to either leave the users currently alone and letting them navigate the tokens or the assets to the chain where the dApp is deployed, or they fragment themselves, needing to maintain multiple instances of multiple rollups, and also fragmenting their liquidity if they have some, and additionally are basically not being able to integrate with other dApps which are not deployed on the same chain. And when that happens, users have to deal with this fragmentation. They have to navigate through the networks. They have to gain the knowledge first about the whole L2 infrastructure. And yeah, really, like, it results in a really horrible UX. I think if you're an L2 user, you probably had this pain already. But if you're a dApp developer, you probably had this pain of like getting attraction from users and from liquidity of different chains as well. So what we need to do typically when you have a growing complexity and you want to really get a usability on your technology, you need abstraction. Today I want to explore how we can get to the state of abstraction of L2s, but I'd really like to focus you on that we are talking about an L1 which is scaling. So in this case Ethereum scaling with L2s. Cross-chain is also, like, there will also always be other L1s, but we believe that scaling an L1 has fundamentally different properties than cross-chain abstraction. So the reason for this is, first of all, L2s inherit kind of the security of the underlying base layer. But also, it's the same community. We are the Ethereum community, and we should see, in a way, the L1s and the L2s as the broader Ethereum ecosystem, the broader Ethereum network. So in a sense, you could argue, is Arbitrum another chain, or is it just an extension of Ethereum? And additionally, when we're talking about and limiting ourselves in this thinking for L1s and L2s, we have different security properties and different technologies we can use to abstract this away. But why do we need abstraction? And I'd like to steal a really nice analogy I saw yesterday in the Polygon movie. For example, if you use a car, you don't need to know how it works internally. You only need to know how to use it, and you have this user experience to bring it to you from A to B. And this is really how we should look at Ethereum and when we want to have mass adoption for normal everyday users. So end users should maybe know about their wallet. They should know the dApp that they are using, but they should never care about the underlying infrastructure and the L2 ecosystem and where the dApp is deployed, where the funds are. They just should be able to use Ethereum securely. So before we go into detail how this abstraction layer or the stack would look like and what we can like leverage, we should really like focus first on what are we actually talking about when we have this fragmented world. So we're talking about interoperability. And interoperability, we have basically 3 types of use cases, or like of categories of use cases, which can be solved differently. So first of all, we can transfer assets. Transferring assets, pretty simple and straightforward use case, but typically users want to use their assets somewhere on some debt. So this is basically investing assets, transferring the assets and do something with it. And then the third, and that is actually like probably the broadest category, is state reading. So typically people refer to as general message passing, but this gives you a mental model of like we want to push some information from chain A to chain B, but what we are actually doing is we just want to know some state of chain A on chain B. And this really depends on the use case, if it's what kind of properties it needs. But I will go into detail a little bit later. So let's go up this abstraction layer stack from low level to high level. So at the very bottom, we have the core infrastructure, the L1s and the L2s. And the very specific thing, and that is why I want to focus today on only abstracting away an L1 and its L2s, or even L3s, is we typically have data availability on L1. And in fact, by having this, we also have the L2 to L2 availability as well. So what we can actually do by having this enshrined into the base layer, we can do storage proofs of what is actually happening. So we have the data there, so we can do storage proofs, what is actually written on chain A, on chain B. With ZK storage proofs, we can vastly improve the efficiency, and there are great teams like Herodotus who are working on that. But what we really can do is, we already have a path to verify the state. However, typically, and as mentioned before, we have this finality latency, and sometimes it doesn't fit for the use case to wait 7 days to read the state. And additionally, there's a lot of research ongoing with shared sequencing, which could also improve state sharing between at least a subset of rollups. But if that is not enough, and we want to have a faster or different properties in interoperability, we need bridges. So that is where bridges come into play. And here we have different architectures which have different properties and have their strengths and weaknesses about how the message is transported, how the state is transported. So there are typically 2 architectures out there, and you can also combine them. One is the optimistic proof architecture, where you basically claim that the state of chain A is like that, and then there's a challenge window where anybody can challenge and basically stop the message if it's a false claim. Then there are consensus-based validator sets, which is a set of validators which just sign what the state of chain A looks like, and you basically have to trust this validator set. And here you can see that the implementation of the architecture is much more critical than the actual architecture type. So it really depends if anybody it's completely permissionless to challenge, or if only a whitelist can challenge. And then also on the consensus-based part, it is really a much bigger difference if there are only 10 validators or if there are hundreds of validators. If there's a high stake, if they have a high stake at risk, or if they have a low stake at risk. But what we can see in the properties here is that optimistic proof architectures are typically more secure but slower. They have a higher latency because we need this challenge window. On the other hand, validator sets, they have an economic bound, which messages that they can transport, but they can do it faster because we trust this validator set. On top, we need a vital and active off-chain network. So if you think about users want to use dApps on different chains, we need these off-chain actors who actually help relaying the messages and the intents of the users, securing the bridges, and expanding on the account abstraction part to even like improve the usability of the whole network. Additionally, with nearly all bridge protocols, we can have a liquidity layer on top. So that is a simple thing. It's simply explained for use cases where you just want to transfer assets and invest them maybe, or like have a user has an intent to do something with assets on a different chain. Typically off-chain actors can just upfront the tokens and do what the user wants to do, and then use the bridge protocol or even the layer 1 storage proofs to get back the tokens on the other side from the user along with a bounty. So this fast liquidity layer really improves on the speed and the UX in this regard. And that is very important, we need an interface around it. And that is where we are lacking in the community, in the Ethereum community. We need to create open standards. Because currently, and I will go into a little bit and say a couple of words about it, bridges are racing against each other, and this is causing harm to the community. So we need to sit down together as infrastructure providers and work together for open standards where dApps can basically build on, choose the protocols and the providers based on their needs, based on the types of messages they want to send, and based on the use cases they want to implement, and gain this abstracted vision of Ethereum and build on it and just fulfill the intents of the users. And so we as infrastructure providers need to provide this to the dApps so that the dApps can actually provide the seamless user experience on Ethereum to their users. And this is like what we are talking about, this abstraction protocol, where we are actively researching on it. So I just mentioned it, a layer where dApps can confidently build on, which has open standards where new providers and new bridge protocols can come in, where you can plug in and plug out. And dApps can choose what bridges to use and what are the properties of these bridges, what they need according to their messages, and allowing like crypto users and people to become crypto users and use Ethereum securely. So where are we today, and why is this not happening today? So if we look at the bridge space today, actually we are in a very unhealthy situation where bridges race against each other, don't collaborate, and just want to get the biggest share of the market. But this results in really a race to the bottom, where the first cut they do and the first compromises they do is typically on security. So it's not, as I mentioned, it's not about the bridge architectures, it's about the implementation. If you look at most of the hacks we have seen in the bridge space, it's actually because they are highly centralized. They are supposedly decentralized, but validator nodes run on the same machine. Poorly executed Web 2 ISAC. So here we, in order to survive and in order to grow the market so that actually we make the market bigger and bridges which are successful can survive, we need to collaborate and need to create this healthy competition. So just a couple of words about Beamer. We are currently a token bridge between Rollups and R1. We are deployed on Ethereum, Arbitrum, Optimism, and since this week also on Polygon zk-AVM. And our biggest goal was to provide seamless token transfers between these rollups, so that users can seamlessly send tokens from A to B as a first use case in this vision of the abstraction layer. Therefore, we have a fast liquidity layer of our liquidity providers, which then basically settle the trades on an optimistic proof architecture, which is completely permissionless. Anybody could challenge that. And if there is a challenge ongoing and there is a dispute, we leverage L1 storage proofs to resolve the disputes correctly. So lastly, we are actively researching and building on this abstraction layer, and we need to understand the needs of the dApps. So if you're a dApp developer, if you're a bridge builder or a core infra builder and want to build the seamless future of Ethereum with us together, please reach out to us. Thank you very much. And if you have some questions, please ask.
Does anyone have a question? No?
What are your thoughts on the recent proposal by Connext on this cross ERC20 template? You mentioned that there's a need to build kind of standards for cross bridges. What are your thoughts on that attempt?
Yeah, that's actually a great question. So I believe the way Connext is working on that is the right approach to create or to propose standards, and so that we can get in discussion and can get into the needs or can get into the needs of the dApps and build together standards. If it's actually the right way to allow bridges to mint tokens, I don't know, but I'd love to discuss and with them. And I think, but it's a very good step to get bridges together and get the people who are working in the space together and actively like debate on standards like this.
Can I ask one more question? So it's not necessarily related to bridges, but Uniswap recently announced the Uniswap X, which of course, it has bridges behind the scenes, but it also goes beyond, chains. But it can also involve, let's say, sexes and other OTC providers and whatnot. Do you feel like in that model you are kind of going beyond bridges, and bridges will not be the only thing to think about when you are combining a uniform, kind of a universal network of liquidity that combines both on-chain and off-chain components?
Yeah, totally. So I think bridges are only like a little piece in this whole stack, and it is, and as you have mentioned, like it can go way beyond even chains. It can also go into like Web2 networks or like sexes or something like that. However, I think there is no one model to rule it all. We have to stick to like different domains and see what's the best solution for the domain.
Another question? Okay. Thank you so much, Frederik, and thank you, everybody.